I'm the only thing between you guys and a beer. So we'll try to make it as quick as possible. So, my name is James Vollmer. I work for Medtronic, based here in the Twin Cities. And ironically, or by circumstance, our DNA is from the University of Minnesota. Earl Bakken was our founder, inventor of the battery-powered cardiac pacemaker. First implant was here at the U. Got a couple of URLs there if you want to go examine Earl's background. Kind of a Harley-Davidson thing, if you are familiar with Harley's first garage in 1903. They built the first pacemakers in a garage in Columbia Heights in 1958. So, trivia, amaze your friends. I've been in data since the earth cooled, or so my kids tell me. Healthcare, manufacturing, all the above. Public sector, we did some CRM. It's not customer relationship management, it's convict relationship management for a couple of states out west. My hobbies, I camp with my wife in our Airstream. I do a lot of DIY stuff, house, cars, motorcycles, etc. And I spoil my grandchild, soon to be grandchildren. So yeah, it's fun. So can't say enough. Thank you. Yeah, so I'm going to give you a little overview of what we do or what we're doing with clinical studies at Medtronic. And again, I focus on cardiology. We're a big company. We've got 15 business units, neuro, endocrinology, surgical, etc. But this is going to be primarily focused on cardiology. So, background. New device. Nobody knew how to interpret the data, other than if you have the programmer that's used to program and synchronize the device. The content and the IP was within our organization. If we didn't get this study done, it was one of those things that said, oh, we'll just use the existing process, existing device translators. They don't work. So can you guys hurry up and build a solution for us? And it's like, okay, yeah, we're data people, we do all that all the time. Most of the existing solution was also on-prem, built on legacy tech. We're traditionally a Microsoft shop. Our DNA is C#. For those familiar with cardiology devices, there's a payload that comes off the device that's then uploaded to remote monitoring. That's usually a proprietary binary format. And then we translate that to something that's machine readable, in our case, XML. Those translators are all like .NET 4, .NET 5. I mean, it's old tech. We're now all in the cloud on AWS. They're in the back of the room here. We also have security concerns about anonymization. The only thing we track is device serial number, no other PHI data around that. We need to ensure we're doing the right things in operational costs. For those that have been to the cloud, the terms lift and shift are evil. And that's what we have traditionally done. We've taken a big SQL server, plopped it down in the cloud, and when we get the first bill from AWS, oh my God. We want to make sure we're leveraging cloud native principles and cloud primitives to minimize OpEx. And above all, secure. We also want to make sure that the statisticians who are doing and reviewing this data have only access to the data for the studies that they're assigned to. We're also growing up as a software organization. Cardiology has about 500 to 750 devs. And it's spread among those that do the programmers, those that do firmware, those of us that focus on analytics, and for those of us that focus on remote monitoring. The solution that's currently used for remote monitoring was first deployed as a POC in 2005. It hadn't changed a lot. So we had to kind of grow up and also look at how taking principles that were developed back in 2005 and now take modern principles like domain-driven design, REST. We had a lot of SOAP XMLs littered in there as well. But it's like, how do we build a modern ecosystem for data and REST moving forward? And Triple D is our road forward for that. We made a conscious decision about 2 years ago to focus on FHIR resources as the foundation for our domain-driven design. We're a healthcare organization, seems to make sense. We had a lot of pushback. It's like, oh, we're different, we're unique. And it's like, give me an example of where a FHIR resource will not meet your needs. And the first thing they said, waveforms. Well, aren't waveforms an array of integers? Last time I checked, it's a sample data type on an observation. Well, yeah, but it's like, as we kept going through it, it's like, okay, we're done, we'll give up, we're going this direction. The beauty of this is now we have a contract between producer and consumer. So if I'm responsible for a domain, let's say patient, I own the domain, I own the schema, anybody can consume that, I can do parallel development. And we leveraged this quite extensively during this 4-month exercise, in that we knew this was the observation, these were the data types we were going to have as part of that observation, and we could, those who were doing translation and those that were doing analytics understood that, so we could do parallel development, do test data separately, and then bring it all together at the end. So we didn't have to go sequential, we could actually do parallel development. So enter FHIR. You would not believe the pushback we initially got, and is to the things I talked about before. I'm a data engineer at heart, a modeler, data architect, and I told somebody, and that's my quote, we would still be debating entity and attribute names if we didn't go this direction. Because somebody has to make a decision. It's like, let's use a standard and move in that direction. We now have a common syntax regardless of the device it comes from. One of the unique things about cardiology is we have devices that have a implant life of anywhere from 10 to 20 years. So think about the tech that's inside of you, and also the data and the formats of that data and how that changes quickly over time. You know, our therapy devices, those that pace you or shock you or defib you, have different characteristics, different payloads than a closed loop monitor. However, there's a lot of the data elements that are similar. We differentiate between those based by device family and device capability. We have a common terminology now across all of our device families. Like any other large organization, we will call the same thing something different dependent upon when it was developed and who developed it. We can now bring that all together in a common terminology across all of our devices. It's extensible. I'll show you some things we did there. And long term, how does this fit with the current standards, which are HL7V2, implantable device cardiac observation, and numerous others, SNOMED, LOINC, et cetera. And feel free to ask any questions as we go through this as well. We also wanted this all on the cloud, where all of our transactional apps are on AWS. What about Windows software in a Linux environment? Well, not everything in AWS is Windows. We're able to take our device translators, like I said previously, which are .NET, containerize them, and run those as a Fargate service. The beauty of that is we're only paying for that when it's executed. So we'll do these, we'll spin it up, we'll tear it down. Yes, a Windows OS spinning up takes a little bit of time, but it's somewhat ephemeral. And you know, again, if it takes 5 minutes to spin up and we do 10,000 of these, then we tear it down. Okay, not that big of a deal. I can't emphasize enough elasticity. And I'll show you some numbers, I'll tell you some numbers about what we do from operating expense, which is really phenomenal. And the first time I told somebody this, they said, no, you're missing a couple of zeros. It's like, no, this is what it cost. We, in short, built a DSL, domain-specific language for our own device data. Okay. Inputs XML, mapping and terminologies JSON. We output FHIR observations, FHIR resources, as line delimited JSON, almost taking a bulk data approach. And then we consume that with AWS Athena, which is also serverless. And that's how we present it back to our statisticians. They can also go back to the S3 assets directly as well. Again, consumed via Athena and Spark. Real simple DSL, redacted some stuff because it's IP. We feed it into Python. That Python's a Lambda function. It does its thing, dies. We're only paying for CPU as we're using it. Our terminology is pretty straightforward. We did elaborate on this a bit because this is our own internal terminology. We'll change that here in the future. But we also had a 4-month deadline to get this out and get it into the hands of our users. Architecture. This is where we probably go away from FHIR and go into data engineering principles. We have to anonymize within region. So we're a worldwide company. We have our remote monitoring solutions dispersed throughout the world. We don't want to have PHI data flying over borders. And actually in China, you can't. So we have to have ways to mitigate that. We anonymize the content in country. Something comes in, it does its magic. We push our images to one central location. Things come in, they're either uploaded manually or through an app or through our remote monitoring solution. We strip out any PHI information and we then replicate that to North America, all with AWS primitives. It's about 5 Terraform modules and probably a single pipeline that does all this work. North America, and then I'll show you the consumer account. Kind of the same thing. It's like, man, that's a lot of steps, but when you think about it, it's really not. This is how you kind of do it anyway. You do this and this and this. Every 10 minutes or every 100 incoming files, we fire a step function. That has an inventory. We have a message. Here's the location of the asset. That does its thing, spins up a ECS or a Fargate container that's Windows-based. We translate that to XML. We then apply the FHIR mapping via a Lambda function. And then we output line delimited JSON. So at this point, we actually have a valid FHIR observation. Device data is inherently dirty. We'll see the same episode more than once based upon the buffer of the device. We'll have to dedupe that. Once you have a common way to represent that data, it's a wonderful way to just take PySpark that you know what that model looks like, and apply that and eliminate those dupes. It's like a 5-line PySpark job. And it's so brutally simple, and it takes like 10 seconds to run. And that's actually on about a half a terabyte of data. End user access is either via the console or ODBC, JDBC, depending upon your tooling. Future, we're trying to get people more cloud native. We want to eliminate cloud to ground traffic. The same tools, same capabilities are native within AWS. Let's leverage those to do the analysis. Most of it's R, so we have RStudio available. We also have Python, Jupyter notebooks. We can do the same types of operations. Consumer accounts. The number one thing that people will do, or used to do, is take the data and move it to another database. It's like, we're 2020s, we can actually probably share that data. So we leverage a primitive called lake formation. We share basically a reference to the location. We don't physically move the data. They pay for the cost associated with consumption, which is $5 a terabyte. So it's pretty inexpensive. I mean, even on a half a terabyte of data, it's $2.50. They can leverage Glue, SageMaker, RStudio, pick your flavor, build their intermediate analyses and data sets, store them locally. They're on the hook for paying for that. but it's really separation of duties. We're focused on producing and securing content. They're focused on consumption of content. Anything we do is instantly made available to them, and then they're also responsible for costs associated with that. Yeah, and again, the noisy neighbor, not that you have noisy neighbor and serverless solutions, but you get a lot of people into an account. Yeah, people can step on each other. We don't want that to happen. Findings. Infrastructure as code. Can't emphasize this enough. We do no configuration via the console. It's all via pipelines. We can take our solution, replicate it into any account in minutes versus how we used to do with like Always On or Hadoop. Man, that was a painful process. The modular approach, like I was talking about before, allows parallel development. We're producing content, they're consuming content. We have a contract between producer and consumer. We would give them test data. We would then do our unit test development and our development and deployment. It all come together at an integration test point. It's also extensible and observable. We're already extending the framework. The logging metrics are all readily available via the console. We get extremely granular costs as a result of that, and also being able to see what's happening in the code versus how historically we did it is on a Windows server somewhere under somebody's desk. You don't have a lot of log aggregation with applications like that. The biggest finding, all this event-driven serverless is, I can't say enough, brutally efficient and cost-effective. Cost per encounter is less than a penny. So we can run clinical study with 12,000 encounters for 120 bucks. And that's the first time I said that. It's like, no, you're missing zeros. It's like, no, 120 bucks. And we showed them, here's how many came in, this is what came out, here's cost per. And they went, on-prem, that was orders of magnitude more expensive. We're already taking these same philosophies and applying this to what we'd historically done with Hadoop and taking serverless with EMR and Glue to do what we're doing with our big data stack. Applying those same principles, and we're seeing the same gains, usually at least a 80% savings in CPU, just in compute and storage costs. The biggest thing, FHIR allowed us to focus on the solution. We didn't debate data model. And again, we would have, because that's what we do. We debate data models. But we were focused on the solution. From conception to implementation, this was a 4-month effort. FHIR benefits, I think I'll be preaching to the choir on this. Semantics and syntax. We have a common ubiquitous way to communicate a finding and observation. Before, you had 5 device families, they all did it differently. We've got one way to do it now. Thinking outside of our walls has an impact as well. Diabetes is looking to do these same types of things. Comorbidity for a person that may have multiple of our devices, which can occur. They may have an insulin pump and a pacemaker or a closed loop monitor. Now we can look at correlation of that data at a patient level. Lineage via extensions. Before, if we saw a difference in something that was emitted, they'd go back to the binary, extract it. It's basically crashing the car again. This way, we have every step of the process captured, persisted in an S3 bucket. We can actually look at that data as it flows through the system and go back to the point of origin. It's all part of the observation. An architectural fit. Aligning data within our data domains. Our domain model is actually starting to become a real thing. And there's a lot of good work happening within software to make that happen. And then sharing of content versus copying it. We pay the cost one time to store it. And people can then consume that by just sharing that asset. It's a big leap for people to get there, but once they get it and they see that, oh, I can run the same query in my console that you can run in your console, and it's the same results, And oh, by the way, I didn't have to invest in an expensive point-to-point interface. It just happened by magic. Then they start to get it. A few more things. Don't be afraid of the cloud. That's probably the biggest thing there. We had a lot of people since we've only been deployed in the cloud since 2020. And taking analytics to the cloud was a leap of faith. Mostly because there's a lot of backdoor things that happen, and when we talk about infrastructure as code and pipelines, that's scary to people. So what do you mean I can't log onto a console? There is no console with a serverless application. They get it now, and we're bulletproof. We're solid. We have static code analysis, security scans. Governance loves us because they love what we're doing from a data and security perspective. We do have happy customers. Our statisticians are like, we can start to iterate and deploy clinical studies. We've got 5 in process at the present time. And again, this is just a start. We would like to take this model and expand it and start to define our cohorts, our lists, our participants, capture consent in a FHIR-centric way. Right now, that's very distributed and very parsed. We want to bring all that together, ideally across the organization. So when we're bringing this data in and bringing it together, now we can do comorbidity studies. We can look at the life cycle of a patient or patients with our devices. Potentially look at data outside of our organization, third-party data. Our cardiologists are inundated. We have this thing called clinician burden, where they're just inundated with data from our devices, our competitor devices, Apple Health Kit. Oh my God, my device says I have AFib. And they'll send it to the doctor, and it's I'll take a look, and then they'll come in and they start to have a dialogue with the physician. So again, all the things from a FHIR perspective will eventually come together as part of this solution. We're just kind of the tip of the spear with what we did. So that's all I have. Again, I'm the last thing between you guys and a beer. Any questions?
There's room for one, I guess. Do you have to snapshot any of your databases? Like, so if we're publishing something in a journal, we kind of need a snapshot of what our data set looked like when that was published, so it's sort of reproducible and blah, blah, blah.
We've built it with that capability. Since we segregate our studies technically, it's a folder within an S3 bucket, and we turn off the pipeline once the study is complete. So it is a snapshot. If we need to do that within a clinical study, we have that capability.
All right, thanks everyone. If you have more questions, catch James at the social event, I guess.
Thank you.